this morning's Tech Talks as part of the big event streaming from Timmins, Ontario. Our next presenter is Skjonsby of RIINO Inc. He's going to talk about applications for monorail haulage. I suspect it's significantly more advanced than the old bucket lines that used to dominate our landscape in Timmins, crossing where Highway 101 is now. But again, I'll let him do the presenting, not me. So, Stephen, come on in.
Check, check. Okay, good morning, everyone. So my presentation today is applications for monorail haulage, brought to you by RIINO. So my agenda is to have a brief company introduction, some honorable mentions for rail use and how we got to this point, the benefits of the technology, the system design, power source, site requirements, and how we eliminate derailments. We're going to compare some haulage technologies to the RIINO. We're going to speak about the incline considerations that have to be taken into account, the underground mining advantage, the haulage cost savings that are possible using monorail. We have one case study using at the extreme small end of hauling 4,000 tons per day as a haulage connector, and a second case study hauling 60,000 tons a day with in-pit haulage. We also are going to discuss some of the innovation opportunities available from our government partners and some closing remarks. So RIINO was started in 2020 by Aaron Lambert after a long stint in mining contracting, and we've seen the opportunity for haulage-based solutions based upon conventional track drifts and raised climbing technology, having something modular that you could put together and transfer ore. My background and how I got involved with this came from my father. My dad, at age 24, started out near Timmins, a little town called Boston Creek, and at 24 years old, built this system to unload 3,000 tons of copper ore onto a rail car. Did it successfully, all by himself. Proof that innovation is alive and well in Northern Ontario. Probably wouldn't do it today, but it was good back then. Some honorable mentions for rail use. We're applying existing technologies to mining. It's as simple as that. There's an incline within the shadow of downtown Pittsburgh that was built in 1870. 190 meters long and a 35-degree incline. It has an average 40-year component life. That is the sustainability of monorail and rail. It lasts for considerably longer than anything else that's on tires. I did a stint, I spent 15 years at Valet. My start-out job was as a rail car dumper, and we were using electric Lokies to deliver ore that were from 1929, and we retired them in 2001. The other honorable mention is Disney's monorail. It's been hauling precious cargo, our children, since 1982. It's 23 kilometers long, has variable inclines, and it's driven by it's a 62-meter long train, driven by only 8 84-kilowatt motors. You can see that 84-kilowatt comparison is similar to what we're looking at. So the technology benefits for monorail is it's carbon neutral. Everyone is talking about having a carbon neutral, zero emission technology. There's efficiency. Rail is by far the most efficient means of transport. You don't have friction. There's autonomous operations. If you look at the SkyTrain in Vancouver, it operates without drivers for considerable periods of time. Might be conductors for people coming back from Vancouver Canucks game, but it doesn't need to have a driver. There's also significantly reduced environmental risk and reduced long-term liability. And that is in part by the compact nature and the compact footprint of a monorail. We only need a 6-foot width. Now we're getting into the system design. The power requirements for the RIINO, we're envisioning a 750-volt DC bus bar. This is lock, stock, and barrel, similar to what you would see on a municipal transit system in any metropolitan city. The auxiliary supply would be a battery, which there are several out there, and it'll have electrical regeneration capabilities when driving down inclines. The drive power is 900 kilowatts to carry a 120-ton payload operating at 10 kilometers an hour on an 18-degree incline. The minimum drive requirement would be just two 75-kilowatt motors powering on a level, non-inclined surface. We can configure this in several different applications in several different manners. We've looked at 240-ton trains down to 60-ton trains. The haulage distance, we're looking and targeting a 1-kilometer distance to an unlimited distance, depending on the economics. The topography, we feel we can handle up to a 20% grade incline. That's the engineered design at this point. The civil infrastructure would be concrete pads when on a soil surface, and bedrock anchoring when you're in an in-pit scenario. The turning radius is very unique. It's a 7.6 meter or 25-foot turning radius. The road width is a nominal 6 feet. This means that we can go through a 7-foot diameter culvert. The ground pressure, we've calculated this, recalculated this, talked to civil engineers. It's less than 1 PSI ground pressure. My foot is like 8 PSI. A car truck is 30 PSI. So very low ground pressure. The rail segments are 6 to 12 meter long rail sections, similar to what you would see when you buy commercial steel supplies from any industrial supply center. The big thing and the big reason why a lot of companies strayed away from rail in 70s and 80s was derailments. And in doing research for this presentation, I looked to YouTube like a lot of other people do. And, one of the big commentaries were, that was the biggest thing that we always had to learn was how to get the train back on track. The training systems were about derailments. The monorail will completely eliminate derailments by virtue of its design. If you look at the tires, you have tires vertically and horizontally, thus eliminating your potential risk. It will be able to handle steep inclines and high speed without any modifications. The picture that I have of the rail cars is actually nearby from Kid Creek. It's been circulating LinkedIn recently, and you can see the guy with the bar getting ready to monitor the train cars so that they didn't derail on the switch. Now, in comparison to other rail technologies, there's a lot of things to consider. It has to be your project application. A 500-ton-a-day narrow vein gold mine probably would not be the best scenario for a monorail. The tonnage just isn't there. So your production rates are a big consideration. Your duration actually is a benefit to a monorail of our style because it's modular. We can disconnect and reconnect, and we feel we can assemble a very long distance in a very short period of time because we're going to have a modular system for installing the rail. And the rails themselves will only weigh 1,500 pounds or less than 1,000 kilos on setup, obviously dependent on your length. The footprint and ground pressures are extremely low. This then obviously aids in the civil design of the road surface. The other operational impact that's positive is monorails don't generate dust, or not nearly the amount of dust as a 200-ton haul truck. The surface area just is not there. The weather effects, unlike a conveyor, which is sometimes weather dependent, you have to keep them going. We can park the drive devices in a thaw shed if needed be, or just keep things running. It does not have the weather effects of tire-driven equipment. I grew up along the side of the ONR Railway, minus 40, the train still went. Snowstorm, the train still went. The monorail will do the same thing. The big other additional benefit is this piece of equipment can run throughout shift change. It's completely autonomous. It will operate and be thus more efficient than individual pieces of haulage equipment. Incline considerations. We can operate theoretically at a 30% incline. You do not lose traction on a 30% incline with a monorail. And in fact, that slide that I presented earlier on the 35-degree incline, the steepest road surface in North America is right adjacent to that in Pittsburgh. That's a 30-degree incline that two-wheel drive Toyota Corollas drive up. So it is possible. By having a 30-degree incline or an 18% incline, we can access the ground much faster at depth. It will also facilitate shallow angle ore deposits that may not have been mined and render certain technologies more feasible to shallow angle mining. By having a 30% incline distance, I'm cutting my distance for development from 3,200 meters to 2,000 meters, a 38% drop in development rate. That's significant. There's existing steep ramps in mines. Historically, incline shafts and steep ramps have been used. They fell out of favor because the powers that be at the time, safety is one of them, pinch points and productivity by having no derailments favored the use of track or tire-driven equipment. Now, the underground mining advantage that we also see is a step change to underground development. We also feel conventional development right now is sitting, when we're talking about ramp development, the standard go-to is the 5x5 meter ramp or drift development. With the RIINO, because we only need that 6-foot width, we feel very comfortable that we can go with a 9 square meter, 3x3 meter development. That reduces your excavated tons by 64%. And in 2012, when Vale and a rail client pursued the 114 ore body, they noticed an increase in development rates by 240%. They were developing in Sudbury 400 foot per week development rates. Very significant. And by doing that, they had an earlier ore production, reduced mine ventilation, electrical consumption was very low, and they had less ground support requirements. Therefore, they could attack the face faster. Now, in terms of costs, we did a comparison using a 42-ton haul truck, and for this scenario, it was $4.30 per ton. That probably would be a little bit higher now based on fuel costs, cresting the $2 a liter. I think it was $2.31 for gasoline this morning. Maintenance costs have gone up. Labor costs likely have gone up as well. The RIINO, because it is electric, the fuel cost is nominal. The maintenance cost, because it's in place, is nominal, and the labor cost is significantly lower because it's autonomous. The other major factor with the RIINO is we can still handle a minus 700 millimeter rock particle. You cannot do that with a conveyor. So truly a unique design for an autonomous haulage system. So our first case study was a 4,000 ton a day remote but grid powered copper gold mine in Canada. We were scoping out the delivery of minus 700 millimeter rock that would be uncrushed, but through a grizzly, likely with rock breakers, hauling 1 kilometer to the crushing plant. It was a fully autonomous operation and would eliminate surface dust, and we were going to use 7-foot diameter tunnels to eliminate road intersections. It was not reliant on any diesel deliveries, and at this site they were paying significant amounts for diesel operating 777 haul trucks that they had in their fleet when they were an open pit producer. The savings on a 3-year production cost was substantial, $8.9 million, and in operating at a longer period of time, just 5 years, it was 17.5. You can really see the benefits when you have a longer length operation with the RIINO, significantly better than anything on a truck. We selected sort of a half RIINO, which would be a 60-ton RIINO, to replace just 2 777 trucks. And this delivered us a 75% decrease in OpEx. Our case study number 2 was a 60,000 ton per day in-pit haulage in South America. This is a very unique ore body in the fact that they were using 777 haul trucks for 60,000 tons a day. You wouldn't normally see something like that, but they had a very broad landscaped operation. So we were looking at 3-kilometer in-pit haulage to the stockpile locations, an automated operation, eliminating the road construction and reducing the operational emissions were significant drivers in this project. We selected 10 120-ton RIINO trains on a loop circuit, and on a 3-year production cost, this cost savings was $64 million, and on a 5-year, it doubled to $128 million. Innovation opportunities. The monorail can be implemented into many new and existing mine operations. Because of its compact footprint, it lends itself to a lot of historic operations that may be too tight for a 5x5 meter equipment. It's very useful for surface haulage, and of course we can look at the steeper ramp development if need be. We have innovation support from a variety of government partners. CMIC, Rethink Mining, is a proud sponsor and a friend of ours, along with Charles at SEMI and Perumin down in Peru. Thank you, and any questions? That's a good question. Historically, trains have been used in areas where there is a requirement for low ground pressure. A very classic example would be the rail line from Winnipeg up to Churchill, Manitoba. It's on permafrost. There is no other, you cannot really put a road to haul significant volumes of material. Yeah, you could put a logging road on it, but that is the significant benefit. The other benefit would be if I'm trying to firm up a tailings area and I had concerns about putting very heavy-duty equipment on top of a tailings berm. At 1 PSI, there is no concern with the RIINO.
What stage of the
We have a prototype designed. We have engineering design completed. We have costing completed. And we are in discussions with a variety of contract firms and mining firms internationally.
So you're probably still looking for venture capital.
Absolutely. With that said, it's been a pleasure being in Timmins, and have a great day, everyone.